I think this question is difficult. You may remember I referred to this last lesson, and I said this question is hard. But what makes it hard? What makes it hard? I think what makes it hard is that none of these are numbers. Well, I mean, they are numbers, but we don't know what they are, right? So you have to deal with pronumerals the whole way through. And when you look at these, I don't know how you feel when you look at those. I think this has all the ingredients of the kind of question that in like your second last or last section of the paper, you just look at it and you say, think I might come back to this one later. It just looks intimidating, okay? But it's not. It really isn't, okay? I know the results look really awkward, but they all flow out of a very simple situation, okay? So, let's begin. Here's what I want to do first. You've got these times that get introduced to you, okay? T1 is when you're at this point in the air. That's why I've called this a mid-air target, okay? So, at this point, the time is time 1, okay? So we want to find what that time is. That's the first thing, okay? Flowing on from that, this point down here, where it lands, hits the horizontal again, that's time 2, okay? So t equals time 2 when it hits, okay? So how do we get some relationships here? The thing that makes this point special, and you can see it on their diagram and mine, is that it's equally high as it is horizontally from where you started, okay? So that's why, I mean, they've got a triangle, I think, drawn in with its dimensions, but I'm going to call it its coordinates HH, okay? Because, well, they call it H as well. So I want to be able to describe this time in terms of all this other stuff in the equation. See that? All these other bits and pieces, okay? Is that a minus? I think it's a minus, isn't it? Yes, it's a minus. So how do I begin? And you want to give me a first step. Where might we start? Where do most projectile motion questions begin? You're going to have to probably resolve the initial velocity, I think, and from there you can get all of your time equations. Okay, so let's do that. Draw yourself up your little resolution diagram, and then you draw your vector in there, angle of projection and so on. Okay, so it's being projected up. You've got u being that initial speed, and then you've got this angle over here. Okay, so from there you can read off initial x dot and initial y dot, right? Because this is at time equals 0. Let's put that in here. At time equals 0. Okay, by now you're starting to predict these kinds of things because you've seen them so many times. Can you tell me right now what's x dot? It's going to be this right angle triangle there, so it'll be u cos alpha, won't it? And in the same way, you'll have u sine alpha there. Okay, so there's my initial conditions. I already know, excuse me, I start at the origin. Excuse me. So now I can form my time equations, okay? What do I start with? What equations do I begin with before I can generate all of my time equations? It's part A. Part 1. Wow, it's early, isn't it? My brain hasn't warmed up yet. Okay, horizontal acceleration, right? We always start there. And in a projectile motion question, how much horizontal acceleration is there?
0.
None. Good. Okay, so you're going to integrate once, and that's going to give you the first constant. Let's do it fully this time, shall we? But of course, using your initial conditions, you can say that that constant will be your initial velocity, right? And in fact, that's going to be the velocity the whole way through, okay? Integrate one more time to get to displacement, right? So you'll get this guy plus the next constant. And because we're starting at the origin, this constant's equal to 0, right? Good. There's all our horizontal time equations. Let's do our vertical ones. How much vertical acceleration is there in this system? It's going to be minus g, and you can tell because g appears in this equation here, so you don't need a 10 or a 9.8 or something like that. So I'm going to have minus g here, integrate once. Constant number 3. Okay, what's the initial upward velocity? It's u sine theta, right? So that's going to be your constant when time is 0. Okay, so you're going to get this. And integrate one last time. final constant. What's the final constant? It's 0, because I start at the origin, right? Excellent. Now I have all of my equations set up. 1, 2, 3, 4, 5, 6. Excellent. What do I do with these things? Remember what I'm trying to prove? I'm trying to get to this. How do I get there? What's special about T1? What makes T1 a particular... What happens at T1? The x and the y values are both the same, right? That's what makes time 1, okay? So I'm going to say when t equals t1, right? My horizontal and my vertical displacement ought to be the same. They're both whatever h is, okay? So I'm going to have this. So now I can take my two displacement equations, right? Instead of having this variable t, I now have this actual time, t1, and I can equate them, right? So I'll do this. Let's see. Here's my x equation. Whoops, it's capital. That's my x equation. And here's my y equation. Okay, suggestions. What shall I do? Remember where I'm headed? What might be a good way, what might be the fastest way to simplify this and get to our result? Whoops, sorry, that should be a 1. We're really asleep, aren't we? I see a common factor. 3 terms, common factor through all of them. I'm going to divide. Now, hold on a second. We usually say, ooh, it's a bad idea to divide by the thing you're trying to solve, right, when you're trying to solve an equation. But it's okay here. Why? Why is it okay to divide? Time 1, where is it? Well, it's after some amount of time, right? You fly up and then you hit this point, okay? The important thing I want to notice about it is that time 1 is not 0, right? It's not my starting point. So if it's not 0, I can divide through by it. That's the first thing. And number 2, I'm not interested in 0 as a solution, which is the solution you lose when you divide through, okay? So at this point here, to justify the fact that I can divide through by it, I need to state it's not 0. That's why you can do this line, because otherwise you're dividing by 0 and you get a nonsensical result. Okay? Now, all I need to do is some fancy rearranging. Okay? I want to make T1 the subject, so let's do that. I'll swap these two guys. Do that. Is that okay? They've switched sides, and now you can see I'm pretty much there, aren't I? I can factor out this u, and I can divide by g on 2 at the same time, which gives me this. Hooray, I'm there, good. Now, like I said, it looks intimidating because it's all letters, right? They've even been, awkward and made G a letter even though they don't have to. But the way we went about it was no more difficult than solving a normal question. Just there are no numbers there, okay? Right, have a look at part 2. How would you go about this? We now want to find the time of impact. That's what T2 is about, okay? How would you go about doing that? And in fact, I believe the question says, hence, it's in terms of time 1. What would you do? I'll let you make a start first before I show you how.